My name is Lily. I'm a final year PhD candidate working under the supervisions of Associate Professor Patrick Spicer under the research group of Complex Food Research. I work with Art O'Connor from our Complex Food Research group and also Lisa and Alex from our industry collaborator Agnetic Bio. They're experienced in biological crop protection formulations and applications, and we are working as a team under the supervisions of Patrick Spicer. So what I'm looking at is a cellulose fibers coatings that help to retain the active ingredients on the targeted surface. So they don't just look at how that lands on the crop surface, but it helps to spread and then to stay where we want them to apply.
We're looking at making microparticles from bacterial cellulose through agitated fermentation. So you'll probably know bacterial cellulose from kombucha. So kombucha, the little kind of floppy thing on the top, people call it SCOBY, that's made of bacterial cellulose. And my project is looking at how we can basically make really small versions of these pellicles on the surface in the volume just by stirring the fermentation. So this has got applications where we currently use synthetic polymer microparticles, but instead we're using this natural material called bacterial cellulose. And so the fundamental side is how the shear-induced aggregation theory works differently with a live biological sample with these really long, thin fibers made of cellulose, as opposed to just polymer spheres aggregating together, because we have a kind of a dynamic system. And then the industrial applications come from being able to scale this up. This has the possibility to scale up for industrial applications. So really, as I'm doing my research, looking at the scalability and industrial capability of the process.
From the broader perspective, looking at this, we can really reduce the waste or the cost of those potential biological applications, and so that's saving the environment and also cost effective.
The challenges that we're trying to overcome here is that we're trying to use a natural polymer to help deliver specific agrochemicals to the point of use while also using less of those chemicals. So by using this polymer system, we're able to basically encapsulate, deliver and keep the agrochemicals where we want them to be. So we're helping to reduce the overuse of chemicals and the need for repeated dispersion of these chemicals as well.
So a lot of the spray formulations applied on the plant or crop surfaces have great potentials because there's a lot of useful additives inside the product. But the problem we are facing at the moment is that those additive particles or materials do not necessarily stay at the way where we want them to stay because of the reality, for example, winds and rainfalls and all that. So that was one of the key challenges we are trying to tackle.
And the great thing about having an industrial partner is that we've been able to use their connections and their industrial partners to do field trials. So when we do experiments here in the lab, we're able to follow those up with field trials as well.
So at the moment, under the supervisions of Patrick, we built a framework so that we run a set of experiments to understand the retention rate of those active ingredients embedded into our systems and how those fiber coatings that actually work, basically the fundamental kinetics or the mechanics behind those films. By understanding that, we can bring this into broader applications, not only necessarily agriculture, but food and personal care products as well. We do have some controlled lab-based experiments to mimic the actual scenario, for example, to mimic the rainfall and all that kind of thing. And Alex and Lisa on the other side, they focus on the field test. And then the good news is that our product or this mechanism has been commercialized, and then the field test showed pretty good results, showing at least 70% of the reduced of the waste of products. So that's great.
The progress in the project has gone really well. Specifically with Agnetic Bio team, we've had a lot of success with the formulation of their products. I've been working with them a lot on both their wet and their dry versions of their projects. We've been doing a lot of flow response, so rheological testing on how the projects work, and we've also had some scale up at their plants internationally. So it's been really positive to see that kind of partners around the world have been starting to trial some of these products that we've been kind of working on in our lab. So it's been really gratifying to see the work that we've been doing is kind of far-reaching and going well. In In terms of my PhD project, we've also had a lot of good progress. We've worked on these bacterial cellulose microparticles, and we've had a lot of success in customizing them. So the second half of my research, after we've finished the kinetic modeling of how these form. So the first half is about how these particles form in the first place and what the methods of growth are. And the second half is about kind of customizing these to specific needs. So that's, I think, where the industrial application really comes in. So if someone wants a smaller particle with high porosity, we've been able to try and start to tune that. So I still have a year and a half left, so still a lot of research to do, but definitely some promising results so far.
I think the journey of collaborating with Alex and Lisa in the past 3 and 4 years really taught me how to fill in the gap between a promising material in the lab to a real practical product in the industry.
They have so much experience in just such a different realm than myself and Lily do. You know, we are here working in the lab, and they'll come to us with an idea, and then we will have to start thinking about, okay, well, what does that mean scientifically? Like, how can we test this in our lab? Having teams like Future Food Systems support industrial programs like this, and getting researchers early experience to industrial application and research is amazing, and it's something I highly value.